Bear in mind also that we're very fortunate to have our next presenter in town. She coordinated her lecture schedule to work with us, and I hate her so much because she got to do that with Patrick Stewart. Ladies and gentlemen, Julielynn Wong.
Thank you very much. It's a real pleasure to be here. And yes, we coordinated my academic lecturing schedule specifically so I could speak at Nerd Night tonight. So I'm really excited. So thanks for coming out. I'm super, super pumped. So yes, so for those of you who are Star Trek fans, just so you know, Star Trek replicators are here. And for those of you who, like me, who are big fans of Captain Jean-Luc Picard, you know that one of his favorite lines is "Tea, Earl Grey hot," and which, of course, he gives that voice command to the replicator in his cabin, and in a matter of seconds, a nice hot cup of Earl Grey tea magically appears, which he can then imbibe and enjoy. And yes, I was very lucky, actually. When I was in New York City, Patrick Stewart was actually performing live on stage on Broadway, and so I was able to meet him backstage and snap this photo on my iPhone. Yay! So, sorry. Oh, just so you know, what I didn't include in this talk actually is a picture of me in a Star Trek uniform at a sort of space-themed party next to an astronaut. So, but we'll do that next time. So. But yeah, so let's talk about 3D printing. For those of you who don't know much about it, I'm sure you've had a chance to check out the 3D printer up here up close and personal. It's very, very exciting technology, and it's something that I'm very passionate about. So 3D printing essentially is a process which allows you to build objects of virtually any shape, layer by layer, and out of a whole diversity of materials. The ones I'm going to focus on are primarily thermoplastic, meaning these are plastic filaments that are fed into a printer head, which heats it up, makes it molten, and sort of spits it out in the layer an eventual three-dimensional shape that you want. But there are other types of materials as well. There are metal 3D printers, and a whole bunch of other different materials that are used, but they are slightly different 3D printing processes. And the ones that are probably most important for all of us today are the thermoplastic ones, which is an example of that is right there in front of us. So there are other names for 3D printing. If you hear the term digital fabrication, additive manufacturing, freeform fabrication, or rapid prototyping, which is originally how 3D printers were used, those are all synonyms for 3D printing, although 3D printing sounds way cooler. So, and as well though, it's important to recognize that with 3D printing nowadays, it's not just for prototypes, but in fact you can get functional end-use products. And what are the advantages of 3D printing? Well, essentially you can have personalized, on-demand, and on-site production capabilities. So just to sort of understand the ABCs of 3D printing, there's a picture of me, and to my left in this image is my 3D printed selfie. And the hand that's holding my 3D printed selfie is actually Dr. Dan Barry, who's a 3-time shuttle astronaut. He was actually a contestant on Survivor, the television show, and he's also a physical medicine and rehabilitation physician. Now, Dan is holding up my 3D printed selfie, but his son, Andy Barry, actually had essentially hacked together a laser surface scanner. And so Andy had scanned my face a few years ago. Of course, when you have your face scanned by laser, you always have your eyes closed. And then was able to upload that digital file to design software, make any required changes, and that was emailed to the 3D printer, which then, in turn printed out that 3D model of my face. And there was sometimes there's post-processing required with 3D printing. Quite often you need support material. So in this case, for this type of 3D printer, we may have had to put that 3D printed object in a solvent bath to sort of dissolve any support material away, and what you end up with is the final product you see there. So what's really interesting about 3D printing is that they are sort of partially self-repairing, and the type of 3D printers that we're talking about today, the fused deposition modeling, are the ones that use the thermoplastic. So the filament feeds through it, gets heated up, and sort of melts in the 3D printer head, and then it comes out on the printing surface. So there is one called the RepRap, and that's an open source 3D printer, and it can print approximately 60% of its components. So if it kind of continues along this trajectory, perhaps someday we may have 3D printers that are able to print 100% of their components, which means, in essence, that we would have self-replicating 3D printers. Now, another advantage of 3D printing is that you can actually reduce waste by recycling unused print material. So the Philbot is a commercially available fused deposition modeling thermoplastic 3D printer. It's about $650 if you're willing to put it together yourself. But you can also buy something called a reclaimer that essentially grinds up unused 3D printer material and creates another filament that you can use. Now, how are 3D printers being used here on Earth? Well, actually, there's sort of a multitude of different applications. Because we only have 20 minutes, I'm going to focus on my favorite 3D printing story, and that is Buttercup's story. So Buttercup started off as a high school biology project, and when he hatched, the students noticed that he actually had essentially the ducky equivalent of a clubfoot. And so he was then adopted by a bird sanctuary center, and they made the decision, along with the veterinarian, to amputate that deformed foot. And so what Buttercup was left with was a little stump that essentially was a little peg leg. So the bird sanctuary owners wanted to do something about it. So they decided that they were going to 3D print him an artificial leg. So what they did is they took about 30 pictures of Buttercup's sister's normal foot on her left foot, and using free software, they were able to create a high-resolution 3D model of a normal duck's foot. And so then they emailed that file off to a 3D printing company. That 3D printing company printed off, prototypes of that three-dimensional file, and you had a 3D foot model. And then they were able to use that actually to eventually create a mold in which they created a silicone sock that sort of you could sort of like pull up over Buttercup's little stump, and he could wear it because it's soft and flexible to walk and swim. So what's interesting is that if you follow Buttercup's story on Facebook, by the way, just so you know, Buttercup has like over 18,000 likes on Facebook. So, I was very interested in Buttercup's story, so I went and checked out the Facebook page, and it turns out that the Bird Sanctuary Center was fundraising for a desktop 3D printer. And this really drives home the point, actually, of the fact that these 3D printers are reasonably affordable. I mean, they start off at about $600. They can go up to about a couple $1,000s, depending on the system, its requirements and the details, and whether you're willing to put it together yourself or not. So when I saw this, I said, I cannot believe that they haven't finished fundraising already, because Buttercup has been on CNN. I said, of course I've got to make a donation. So what happens is when you make a donation, well, I guess a sizable donation to this Bird Sanctuary Center, they actually send you a prosthetic foot. So I'm going to pass this around here. This is 3D printed, and it articulates. It's got an ankle and knee joint, and Ross is going to pass it out here. Hopefully I'll get that back at the end of the evening. But now the other thing to keep in mind as well too, and I hope that this will change in the future, is that the cost of 3D printing material, particularly that plastic filament, is not inexpensive, is the best way of putting it. It's about $30 US per kilo. But there are folks out there working on creating 3D printers that can use plastic waste and recycle that and as potential printer filament material. So let's talk about my next favorite topic, which is 3D printers in space, because that's where they're headed. So very, very soon, I can say sometime this year, with a large degree of certainty, NASA will actually be launching the first fused deposition modeling thermoplastic 3D printer on board the International Space Station. As well, last fall, the European Space Agency announced that they have launched something called the AMAZE project, which is essentially a collaboration of industry and academic partners. And their overall objective is to develop the first metal 3D printer for space. So remember, 3D printers, they're like 3D photocopiers, or once they hit space, you can really think of them as Star Trek replicators. So why are we putting 3D printers in space? Well, there's a huge advantage, because now you have the potential capability to manufacture tools, replacement parts, even food, and planetary habitats on demand. And the real key advantage right now, that's quite clear, is that you can really minimize your spare parts inventory. So right now in space, we essentially fly triplicates of everything, because we don't know what's going to break down. And you're not just going to be able to run out to the hardware store and get a replacement up in the International Space Station, right? So you've just got to bring a whole, 3 of everything in your inventory and just hope and pray you cover everything. So if you can just produce the replacement parts on demand, that's going to save you a lot of money. And as well, that's going to enhance the self-sufficiency of a long-duration mission like a lunar or Mars mission. So for those of you who are fans of the movie Apollo 13, which I am, of course you know that's based on an actual mission and true events. And what's very, I guess, sort of beautifully depicted in this movie is the fact at some point they actually had to do some serious hacking. So essentially, the astronauts had to improvise a carbon dioxide filter holder in order for them to be able to survive the trip back home. And so there's a very sort of famous line where the engineers in mission control basically say, we have to make this, fit into the hole made for this, using nothing but this. And on the table is just a bunch of stuff that they know was in the spacecraft that was taking the astronauts back home. So they eventually did manage to hack something together. They put together, I think it was gaffer tape, manual cover, and a plastic bag, and were able to create this makeshift carbon dioxide filter holder. Well, if you had a 3D printer on board, you would have just been able to print and solve this problem in about 30 minutes. So it's a huge advantage. So I was very fortunate. I have some good friends, and they started this 3D printing for space company, and they invited me to do parabolic flight testing on board NASA's Vomit Comet with their 3D printer that's now headed for space. And so that's me in, I guess, the flight suit there, and we're actually in the interior of the KC-135 zero-G aircraft, and I've got my hand on the 3D printer there. But actually what's really interesting is when you do research parabolic flights with NASA, there is always a flight surgeon, meaning a physician who specializes in space medicine on board. So because I happen to be a physician, of course, I started chatting with a flight surgeon, and they asked me what I was doing, and I explained to them what 3D printing was, and I must have sort of sparked some sort of interest, because a few months down the road, they came back to me and they said, well, we have this question about 3D printing, and this was brought up because essentially Antarctica is probably our best analog for a Mars mission. So we have quite a lot of data, and the reason why is obviously Antarctica and Mars are pretty similar. They're remote, they're austere, they're alien environments. You've got resources that are constrained, and so when you actually look at the data in terms of the medical case logs in Antarctica base stations, you'll find that some people develop appendicitis, which is an infection of your appendix, and the way that we treat that is surgical. So in fact, there was a very, depending on your point of view, unlucky Russian surgeon who was posted to Antarctica in the 60s, developed appendicitis, realized he was going to have his appendix taken out, and the only person who was going to be able to do it was him. So that's what he did. He took out his own appendix. And so, yeah, that took some serious testosterone, and in surgical parlance, we would refer to this individual as hardcore. So, and as well, more recently, back in 1999, we had Dr. Jerry Nielsen, who was an ER doc, who was also stationed at Antarctica and discovered a breast lump, and also had to do her own surgical biopsy of that breast mass, which did turn out to be breast cancer, unfortunately. She did have to administer chemotherapy. Initially, her cancer did respond, but she eventually died about 11 years after her diagnosis of metastatic breast cancer. So clearly, surgical problems can arise on Mars based on the data when you look at what's happened in Antarctica. So now the other problem is that we've got limited surgical capabilities in spaceflight, right? You're never going to be able to take all the stuff you want because, cost constraints, which is going to limit how much, mass you can take and how much volume you've got. So what do we currently have? Well, we have basic life support and advanced trauma life support capabilities. Okay, that's good. So if something bad happens, you can probably, keep somebody alive. But in terms of, very specific surgical kits, all we have really is an emergency room suture kit to treat basically minor lacerations. It's not very It's not very good. So as well, you're going to have uncertainties about what surgical problems might arise. You just don't know. There's a whole bunch of things. Who would have thought that someone would have developed breast cancer in Antarctica? That's something that would have been really, really difficult to predict. So we have that same challenge when it comes to a Mars mission. And as well, you might not have a surgeon as part of your crew as well too. So currently, right now, in terms of the surgical skills that the crew medical officers and their backups are given, essentially they're trained to perform single-layer instrument closures, which is something that I taught Kim's students today, who are undergrad students. So the very, very sort of basic surgical skills. So because of this, right, because we look at Antarctica and we realized, wow, potentially we might have surgical problems arising on Mars, because of the fact that we know we've got a limited surgical capabilities, NASA came to me and said, hey, could we 3D print surgical instruments if we had to take out someone's appendix on Mars? And my answer was, of course you can. I told you that back when we were in 0G. So what I did is I worked with another engineer, fantastic guy. His name is Andy Fannell. He's a medical device engineer based in Minnesota. He works for a company called DeviceX, and we've partnered together on this. And we've come up with 10 instruments, and they're modifications of current instruments that are used here on Earth. The materials are different, so the instruments look a little bit different. They're a little bit thicker because the thermoplastic doesn't have the same properties as stainless steel. And I actually had them tested by 13 Albertan surgeons who completed simulated surgical tasks. And we found that they were able to perform all the tasks successfully with the 3D printed instruments. So another issue that comes up in spaceflight are dental problems. I'm actually related to a lot of dentists, and it turns out that dental issues are ranked as high probability, high impact in spaceflight, meaning that there's a good likelihood they will occur, and if they do occur, they're going to impact the mission. So as a result, we have a dental kit that's currently flown on board the International Space Station. Now I have a picture of Chris Hadfield here, and the reason why is not because I think he has bad teeth. I'm sure his dentition is fantastic. It's because I actually had lunch with him when I was training in space medicine at Johnson Space Center, and he had just finished his dental training, actually, because he was the backup crew medical officer for his last mission on the ISS, where he was mission commander. So he told me about that. And I found out, actually, that the crew medical officers and their backups are trained to perform nerve blocks, which is essentially numbing up your face when you have to do things to people's teeth, taking out people's teeth, replacing fillings, re-cementing crowns, and draining dental infections. So how can you use 3D printing in this setting? Well, it turns out to replace a filling temporarily or re-cement a crown, you need 2 instruments. And one is a spatula, and the other one's a brush applicator. And so I was approached by a very enthusiastic medical student. His name is Mitchell George, based in Texas, who has an engineering background and is an aspiring surgical resident. And he wanted to get involved with my project. I said, great, I've got the perfect assignment for you. I said, here are my 2 instruments. I want them combined into one. And this is the CAD drawing that he sent me. And so why is this combined instrument an advantage in spaceflight? Well, it's because it's really expensive to launch mass into space. It costs anywhere from $4,000 to $11,000 US per kilo of mass, depending on the launch vehicle. So if you can reduce the mass of what you're using, that's going to be an advantage, and that's what we showed here. And as well, you're also going to decrease storage volume use as well. So I'm also very fortunate. I was recently invited to work as a flight director at Canada's only Challenger Learning Center, which is a high-fidelity Mars and lunar mission simulator. We actually have a mission control and a spacecraft. And part of the cool thing about the job, too, is I get to also come up and create new mission tasks. So that's what I've done, actually. And so what we have here is our two 3D printed tools, a simulated patient that bears an uncanny resemblance to Chris Hadfield. And essentially what we're doing is we've got a dental emergency, and we'll have the kids understand the concept of 3D printing and choose the optimized design, and hopefully get to replace the filling like here. So there he is, cavity filled, hooray. So yeah. Now another issue that comes up in spaceflight as well too are hand injuries. So when you're in space, essentially your hands, your upper extremities, are your primary translation tools. The way that we get around here on Earth is we use our lower extremities, our legs and our feet. So, but up in space, you're kind of grabbing everything and you're using your hands. So as a result, your hands are actually, or hand injuries are the predominant musculoskeletal injuries that we've seen in American astronauts. And examples of injuries you might have are abrasions, bruises, sprains, joint dislocations, and fingernail loss. And these are caused because you're transferring equipment, you're translating through the spacecraft, you could be impacting structures, and as well the spacesuit gloves are pressurized and they're actually really, really hard on your fingernails. And so what do we have to treat hand injuries in space? Well, right now there are these prefabricated finger splints that are currently flown on the International Space Station. Now that got me thinking, what are the most common hand injuries here on Earth? And there's one very common injury, those of you who play sports may have experienced this, and it's something called a mallet injury. And essentially when you have a sort of force, a sudden force impacting your fingertip, you can actually rupture your extensor tendon right on your fingertip. And the way that we treat this here on Earth is actually we have to splint your fingertip and that distal joint and what we call extension, so out like this, so it's not flexed, but an extension like that. And it has to be continuously splinted for 2 months. And I'm not kidding, like 24/7, like that splint cannot come off. If it's not properly treated, you can actually develop some permanent disfiguring complications that can impact your hand function. So it turns out actually, there have been studies, and the best way to treat these types of injuries are not prefabricated finger splints, but in fact a customized circumferential splint. And so how do we make those splints here on Earth? Well, you usually have a trained hand therapist, and they take a sheet of ABS thermoplastic, and they cut it out into this little L shape here, and then they dip it in some warm water, which softens it up, and they wrap it around your finger so it totally molds to your finger, and they actually put it on your finger so your finger sort of stays straight like this, but you can still move your middle joint there. And that, unfortunately, is not available here, sort of up in space. So what I'm suggesting to NASA is that we 3D print these if we ever have mallet injuries, which could plausibly happen in space because we have a lot of hand injuries. And so you could obtain measurements, you could take the measurements that we use to design the personalized spacesuit gloves we have for astronauts. You could do, if you had a laser scanner, you could scan it, you could take a whole bunch of pictures and create a high-resolution 3D model. And then the 3D printers that are going to be in space use ABS thermoplastic, which is the same material, and as well you need a little Velcro strap to sort of insert it, the splint, and keep it in place. And there's tons of Velcro on the International Space Station. You just pull some off the walls. So that concludes my talk about 3D printing on Earth and in space. And does anyone have any questions?